Our last talk for the afternoon is Habitat Scale Considerations in Bridging the Gap in Region-Wide Data Set, Existing Data and Successful Models, and Mike Hillis from ERG is going to speak.
So thanks, Greg. I'm going to continue the theme of using data, and specifically remotely sensed data, to identify habitat, and then also look at some models to predict how those habitats change over time based on different management scenarios or climate risks or whatever. Management focus the last couple of years has clearly been focused on avoiding take, understand all that. I think as Andrea and some other people have said, it's equally important to understand the status of populations at different scales, certainly at broad scales. And I think the same thing goes with habitat. It's really important to understand habitat, especially when you can corroborate habitat with actual nest data. So in other words, populate the habitat with nest data. And certainly as a tool for prioritizing management actions, given that all of us operate under limited funds, as has been said many times, important to know where to put your money. I'm going to talk about using remotely sensed data and models to identify nest habitat. I'll give you some examples of some different raptors where we've done that. In terms of amount, location, arrangement, and also the potential to corroborate that with actual nest data. And then in terms of modeling, I'm going to talk about how to predict how that habitat changes over time from natural disturbances like fire, insect, disease, invasive species, whatever, or human disturbances, energy, grazing, fire suppression, things like that, or and particularly under different climate scenarios. And I'm not going to go into all of that, but I'll at least provide you a couple examples and also reference some other models that do some of this stuff that I'm not going to show you examples of. Remotely sensed data, talking basically about satellite imagery, vegetation layers, which includes such things as cover type. Is it cottonwood? Is it grass? Is it sagebrush? Whatever. Or size class, height, different size classes of, let's say, forest vegetation, if you want to think in that terms, and or density. Usually we combine those with digital elevation models that give us such things as elevation, aspect, and slope, which may be useful predictors for some species. The cool thing about remotely sensed data, these are site-specific polygons that are explicit, so you can also look at things like minimum patch size or arrangement. In other words, is it blocky or is it linear? What's the position on the slope? Those kind of things. Satellite imagery gives us really good data for forested environments, and I'll talk about the challenges of going from forested environments to prairie environments in a few minutes. But basically, people love using satellite imagery to predict things in forested environments, and they generally get kind of iffy when you try to do the same things in prairie environments. But we'll also talk about that as well. So again, remotely sensed data identify habitats within nest stands. It could be large, dense. You can put minimum patch sizes as a way to identify habitat across the landscapes. I'm going to use the exercise for goshawks because it's a really easy species to predict nesting habitat for in forested environments, and it's one that it typically comes up as an issue across the West. So looking at our landscape here with Gillette in the center, I'm going to focus on the Black Hills. They happen to have, in 2004, they had 100 and some identified nests. Obviously, a lot of those are alternates within much less number of territories. Nonetheless, fairly extensive data on nests. You can see the cluster there. I'm going to zoom in on kind of the Wyoming portion of the Black Hills, that little area up there in red. That's the area we're talking about. So the colors there represent different size and density classes. It's probably hard to see, but there's 3 nests kind of in the bottom right there. And they happen to be almost all of, let's say 90% of the nests are in 2 different structural classes, basically large, very dense, or large, moderately dense. So the orange represents large, very dense. The light orange represents large, moderately dense, which explains 90% of the nests on the forest, okay? So basically we focus in on that large majority to tell us where goshawks like to nest in the Black Hills. Happens to be, of course, totally consistent with what the research would say across the West. And we, when we winnow out the stuff that doesn't fit in those two categories, that provides kind of a crude predictor of suitable nest habitat on that little portion of the Black Hills. So sort of makes sense. I could do the same exercise, just pulling data out of the research. So typically goshawks like dense, multi-storied, large, minimum patch size of 30 acres. But there's certain elevational range that's pretty broad. I'm gonna, just because I'm more familiar with data in southwestern Montana, I'm gonna use that as an example of what you can do with that. The little blue dots represent nests. There's I don't know, like 80 of them or something on the nest. You can, if you look closely at that arrangement, you'll see that there's some obvious alternates of the same territory. So you can see a little territory, yeah, you know, those are alternates for the same bird. This is alternates from the same pair, et cetera. So that gives you some kind of interesting information. If you look at the blue polygons, those are predicted nest habitat based on the same exercise I just did in the Black Hills, based on, again, that typical arrangement of large, dense, multi-storied, minimum patch size. And you'll notice a few things. The nests, no surprise, generally show up in the habitats predicted. So you can kind of say, well, the nest data is sort of corroborating our query pretty well. There's some conclusions you can make. Nests tend to be at the lower elevation portion of the landscape. So in other words, even though we've got habitat kind of scattered across there, up to about the upper elevation limit that they'll nest in, most of them are kind of near the valley floor. That's sort of where the bigger trees are, but it's also perhaps where you maybe have better foraging habitat, better mix. Given that goshawks are foraging generalists, you know, you might expect higher fledgling success or more nest attraction in those areas where you've got more of a mix of forest and non-forest. Excuse me. Another thing is that the territories are generally occupied, and what I mean by that is if you go back and start divvying up the landscape into 5,000 to 2,000 acre potential territories, then most of them have a nest in them or a cluster of alternates. So that's kind of interesting. I make that conclusion without knowing anything about fledgling success or prey availability